Afternoon, guys. I'm hoping that you guys get to these notes today instead of waiting until Saturday or Sunday to do them. But just in case you don't, I hope you guys have a good weekend, and I look forward to seeing you guys on Monday. So today we're going to be talking about probability. And we're going to be starting with just some basic probability. All the probability we get into in this class is going to be very basic. So our objective is going to be students will be able to compute the probability of a single event with 90% accuracy on their 10-question assignment. As I said, probability is pretty easy, so I'm going to have a higher standard for something like this. A few words you need to know: outcome, sample space, event, complement of an event, odds, and then theoretical probability. The formula for it is the probability of an event equals the number of favorable outcomes divided by the number of possible outcomes. We're going to be using this as we're doing the 3 examples today. So, example number 1. What is the probability of rolling an even number on a 6-sided dice? So you have a 6-sided dice. You guys know what they look like. They have the numbers 1 through 6 on them. And it wants to know what's the probability. Okay, so probability is represented by P of an event. So our event is that it's going to be an even number. And on a 6-sided dice. So on a dice, you have the numbers 1, 2, 3, 4, 5, 6. I'm going to underline the even numbers, 1, 2, 3. So favorable outcomes. If I roll a dice, how many of those outcomes are going to be favorable, meaning that they're going to be even? There's 3, because there's 2, 4, and 6. And how many total possible outcomes do I have? Well, I have 1, 2, 3, 4, 5, 6. I have 6 possible outcomes. So this says that the probability of rolling an even number is going to be 3 over 6, which I would simplify to 1/2. And that would be the probability of rolling an even number on a 6-sided dice. Example number 2, okay, a little bit longer, but similar type of problem. So it says our solar system's 8 planets in order of least to greatest distance from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You will randomly draw one of those names of the planets and write a report on that planet. What is the theoretical probability that you will select a planet whose distance from the sun is less than Earth's? Okay, so we have the probability of distance less than Earth. Okay, so again, you can start with finding favorable outcomes, or you can start with finding out how many possible outcomes. So I'm going to start by finding out how many possible outcomes I have. Well, we are talking about the 8 different planets, which means my total possible outcomes is going to be 8. Well, how many of them have less distance or shorter distance from the sun? Well, you have Earth right here. These are all large or greater distances from the sun. So that would leave you with Mercury and Venus as your only 2 that are shorter distances. So it's 2 over 8, which is going to simplify to 1/4. So the probability of when you draw a planet, that the planet you draw is going to have less distance, is going to be closer to the sun than Earth, would be 1/4. Okay, probability is pretty simple. Okay, guys. So, example number 3. In the taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 samples of drink B, 10 samples of drink C, and 10 samples of drink D. What is the probability of a participant not getting drink A. Okay, so we have the probability of not drink A. So again, you can start, you can either find the total favorable or the total possible outcomes. I think finding the total possible outcomes first is the easiest. So you're doing 50 participants are randomly given drinks, 20 are A, 10 are B, 10 are C, and 10 are D. So how many possible outcomes do we have? So when it's basically saying how many different possibilities are there. Okay, well there's going to be 50 people drinking it, which means there's going to be 50 possibilities. Okay, now out of those 50, how many of them are not A? Okay, so not A would mean that it would be B, C, or D, correct? Right, because if I say, okay, we got B, is that not A? Yep. If I say we got C, well that's not A. And if I say we got D, well that's also not A. So these would be the choices we're looking at. Well, for B, there are 10. For C, there are 10. And for D, there are 10. So if I add those up, I'm going to get that there are 30 out of 50, which is going to simplify to 3 over 5. So the probability of you getting a drink and it not being A is going to be 3/5. Okay? This is really all there is to probability. It does get a little bit more advanced if you start dealing with independent and dependent and some other stuff that goes with that. We're going to get a little bit into it, but we're not going to get too heavy into it. There's probably only going to be one more night of notes between now and Friday. So just make sure you guys get these notes done over the weekend and make sure you come up with steps, or if it's easier for this to write a summary, get a summary written. Remember, it's after each example, get the definitions written down. If you have any questions, please ask the question, write it down so that you remember to ask on Monday, and we will have a warm-up on Monday as well. So make sure you guys have a great weekend, and I will see you guys on Monday.